Hi everyone, so today I'm going to be extending the graphs of exponential functions, and we're going to be looking at cases where you might have a reflection of some sort. Okay, so we have this function y equals -3 times 2 to the x, so it's of the form y equals ab to the x. Okay, so I want to remember that's an exponential function. How do I recognize it? Well, because when the exponent is the variable, it's an exponential function. Okay, so we can tell if it's growth or decay by the b term. B is greater than 2, or greater than 1, so it's growth. But we want to look at this function because this function is actually being reflected, because you see that negative that we have in front. And we know that when we put a negative in front of the function, it's going to reflect it over the x-axis. All right, now if I want to think about this, I want you to think about or consider that our parent graph, exponential functions, you wouldn't want to say b to the x is our parent graph because it doesn't have a number. So if I'm really thinking about this as a parent graph, the parent would be y equals 2 to the x. Okay, that would be the parent function. And so the 3 would be vertically stretching it, and the negative would be reflecting it over the x-axis. Okay, so that's actually a verbal description of what's happening. So we have a reflection over the x-axis, and we have a vertical stretch of 3. Okay, so now with this function, we know that our domain and our range, we can put any value in for x, so -infinity to infinity. And because it's not being shifted up or down, we know that our range is going to have something to do with the asymptote. So let's start there. We know that the asymptote would be y equals 0. So we know we have this horizontal line going through y equals 0. Okay, I'm going to find my y-intercept. So my y-intercept would be 0, -3. Remember, we talked about the fact that the a term, as long as it's just raised to the x power, would be our y-intercept. But if you forget that, you just let x be 0 and solve for y, and you get 2 to the 0, which is 1. 1 times -3 is -3. We know our asymptote is y equals 0. So let me plot that point, 0, -3. So you can see already it's over the x-axis. So I want one additional point. I'm going to try 1. Okay, if I plug in 1, I get 2 to the 1 is 2. 2 times -3 gives me -6. Okay, so I have 1, and then 3, 4, 5, 6 right here. Now, I'm going to do one more point because you might not have picked 1. I'd like us to pick -1 because I want to remind you what happens here. So if I pick my -1, then what I have here would be, let me get this out of the way, I would have -3 times 2 to the -1. We know anything raised to a negative power would be -3 times 1/2. So -3/2. So -1/2, right? So that would be -1, 1/2. Okay, so I have enough now for my graph. I'll do my best to draw this. And there is my exponential graph. So you can see that really, really nice reflection. Okay, now let's look at a reflection over the y-axis, okay? So this function is different. You notice that the exponent is negative. So when I'm thinking about that, that's kind of inside the function. So remember, inside the function, inside changes x, outside changes y. So if I'm changing my x values, I'm going to take all my x values and I'm going to go from positive to negative. It's going to be a reflection over the y-axis. But when I look at functions like this, I actually want to rewrite them. I just think it makes it a little bit easier. So if I think about this, I can really say this is y equals 3 times 1/2 to the x power. Now let me explain kind of how I did that. 2 to the -x really means 2 to the -1 to the x, right? Because power times the power, and that would be 1/2. So that's how I did that, the algebra there. Okay, so now I know that we have a decay function, right? Because the b term is less than 1 but greater than 0. All right, verbally describing this. So if I'm verbally describing it from here, okay, there's a couple things I could say. I could say that the parent graph is 2 to the x, right? Y equals 2 to the x. So I could say that it is a vertical stretch of 3 and a reflection over the y-axis. So that would be if I was looking directly here. Or if you were looking at this function, you could say the parent graph is 1/2 to the x. And so this one would just have a vertical stretch of 3. So if you state what you're using as your parent graph, then you can write your verbal description based on it, okay? All right, my domain and range, I can still put in any value for x, so it would be -infinity to infinity. My asymptote is still going to be y equals 0. My y-intercept, let's see, I plug in 0, my y-intercept is going to be 3. So let's get that going. There's my asymptote. Let me switch colors now. I have 0, 3. I'm going to plug in a point. For me, I'm going to plug in -1. Why? Because it makes this a really pretty, easy graph to work with. So that gives me 3 times 1/2 to the -1, which means 3 times 2, so 6. Okay, so -1, 6 up here. And so I can see that it became a decay function. I can also see that if I was looking at 2 to the x, it's a reflection over y. So I'm going to just draw that in so you can see it really quickly. This would have been the 2 to the x graph, right? 3 times 2 to the x. And so you can see that the reflection over the y-axis just flipped it. Okay. All right, and I noticed that I forgot my range on this one and the last one. So my range, 0 to infinity, not including 0 because it's above. It's never going to touch that asymptote. And did I miss it on that last one? I did. So this would be -infinity to 0 because we always read our graphs from least to greatest. And so we're starting at -infinity going all the way up to 0. All right, hopefully that was a helpful video. Have a great day.